Homework 13, question 2. In part 1 we've been given a trig equation to solve, tan x minus 40 equals 1.5, solving for x between negative 180 and 180. Now whenever we have a trig function of something more complicated than just an x, I would suggest making a substitution to an alternative letter and changing the limits and solving that easier equation over a larger or smaller range. You can use any letter you like. I was always taught to do it with phi, and so that is what I've always used. Tan phi equals 1.5, where phi is equal to x minus 40. When you do this, you can change the limits by substituting in your lower value for x and your upper value of x and finding a new range of values for phi. So 180 take away 40 is 140, and negative 180 take away 40 is minus 220. So now we just have a more straightforward trig equation to solve over a slightly different range. Using a calculator, you find that the first solution is that phi is equal to 56.31. For tan, we find alternative solutions by adding or subtracting 180. Adding 180 to that is going to take us beyond 140, but taking 180 away from that gives us minus 123.69. But we weren't asked to find phi, we were asked to find x, and we can find x by adding 40 to our values for phi. So x is 96.3 and minus 83.7 to one decimal place each. In part 2, part A, we're asked to rearrange the equation sine theta tan theta equals 3 cos theta plus 2 into the trig quadratic 4 cos squared theta plus 2 cos theta minus 1 equals 0. Let's start by writing tan theta as sine theta over cos theta. So this gives us sine squared theta over cos theta is equal to 3 cos theta plus 2. If I multiply both sides up by cos theta, I get sine squared theta is equal to 3 cos squared theta plus 2 cos theta. And I want to use the trig identity, sine squared theta is equal to 1 minus cos squared theta, equal to 3 cos squared theta plus 2 cos theta. And if I rearrange this equation, I get 0 is equal to 4 cos squared theta plus 2 cos theta minus 1 as required. Part B requires us to solve this new trig quadratic. If it factorised, I'd put it into 2 brackets, but this one doesn't. So I'm going to use the quadratic formula that cos theta is equal to minus 2 plus or minus the square root of 4 minus 4 times 4 times minus 1 all over 8. This gives me cos theta equals 0.309, or as an exact surd, that was minus 1 plus root 5 all over 4, or minus 0.809, but as an exact surd, that was minus 1 minus root 5 all over 4. This one gives me a solution of 72, and I can find alternative solutions for cosine by subtracting the one I get from 360. So that gives me 288. Well, from this one, solving inverse cos of minus 1 minus root 5 over 4, I get 144, and taking that away from 360, I get 216. And so to finish off, putting them all in order, theta is equal to 72, 144, 216, or 288.